All right, let's jump back into those LMMs. We've come a long way, haven't we, from like what they even are to that whole transformer thing, how they learn from like mountains of data. It's wild.
We have. It's been quite the deep dive so far.
But now it's like we're taking these brilliant students, all this potential, but they need focus.
Ah,
And that's
yes.
where fine-tuning comes in, right? Like turning that raw power into something really useful. And that's what y'all are interested in, judging by the emails, the research papers, even some handwritten notes. You want to know how to mold these LLMs into something special.
It's like taking a powerful tool and then you sharpen it for a very precise job. It's fascinating, really, how we go from training with all that massive data to fine-tuning with these smaller data sets. Very specific.
Right. So just a quick reminder for anyone who's just joining us, we've got pre-training where the model learns like the basic rules of language. Huge data set. But then we have fine-tuning where we tweak things using a smaller, more focused data set. Why is that difference so important?
Well, pre-training gives the model this broad understanding. Like, imagine someone who studied grammar or vocabulary, all of it.
Okay, got it.
But fine-tuning, that's where we turn that broad knowledge into expertise. Like, they understand science broadly, but now they're specializing in astrophysics.
Makes sense. So it's like we're turning these LLMs from general into socialists, ready to tackle very specific things.
Exactly. And that's where the practical applications come in. They go from being, well, impressive, but kind of generic, to being super skilled. Sentiment analysis, questions and answers, translation, you name it.
So one of your sources really dives into supervised fine-tuning, SFT. Seems kind of straightforward. You feed the model labeled data, like classic machine learning.
You got it. Supervised fine-tuning. We're giving the model clear examples, like think of flashcards. One side you have the input, maybe a movie review, and the other side, the label, the sentiment, positive, negative, or neutral.
So with enough of these examples, the model starts to pick up on the patterns. Like, what makes a positive review different from a negative one?
Precisely. And it's not just sentiment analysis. The same idea applies to all kinds of tasks. Categorizing news articles by topic, you feed it labeled examples. Question answering, you give it those question answer pairs. The key is the right data set for the job. It's like a tailored curriculum, right, for a specific subject.
Makes sense. But here's where things get really interesting, at least for me. You also sent me some info on instruction tuning, IFT. This is where we go beyond just recognizing patterns. We're training models to actually follow instructions.
Ah, yes, instruction tuning. This is exciting. We're moving past those simple input-output pairs. We're teaching the model to understand commands and execute them. Makes it so versatile.
It's like saying, hey, LLM, translate this into Spanish. Or write me a story about a robot who falls in love with a tree.
Exactly. The possibilities are huge. You could tell it to code something very specific, or summarize a complex document, or even write different kinds of creative content. And what's really interesting is where that data for instruction tuning comes from.
Oh, you know, I love when things get a little mind-bendy.
Well, some researchers are doing it manually, crafting the instructions and outputs themselves. Others are cleverly repurposing old data sets to fit this whole instruction following style.
Wait, one of your notes mentioned something even crazier. Using LLMs themselves to make more data for instruction tuning. How's that even possible?
It sounds strange, but it works. They're using existing LLMs to generate those synthetic instructions and outputs, which then feeds into the training process for the new models, so we can scale up the creation of these data sets without doing it all by hand.
So they're like teaching each other, becoming more and more sophisticated. Wow. But even with all this AI magic, it seems like humans still play a role. You mentioned human in the loop for quality control.
Absolutely. It's super efficient, this LLM-generated data, but it's not always perfect. Think of it like an apprentice working with a master craftsman. They learn a lot on their own, but they need feedback, that expert eye, to refine their skills, to make sure the work is top-notch.
Right, right. Sometimes you just need that human touch. Speaking of, another one of your sources dives into preference fine-tuning. This one seems less about specific tasks and more about, well, taste.
You've hit it right on the head. Preference fine-tuning gets into that subjective area, right? Sometimes the right answer isn't so clear. It's about style, about tone, maybe which summary is more helpful, more engaging, that kind of thing.
So how do you even begin to train a model on something like that? On preference, you can't just give it rules for what good writing looks like.
You can't. It's a different approach. Instead of saying, this is the correct answer, we're saying, this one is better. According to human judgment, that is. It's more like a baking competition. The judges give feedback, they compare, they don't just declare a winner.
Okay, I'm getting the picture. But who are these judges for the model? Are we talking like literary critics or something?
Not quite, but the idea is similar. It's humans. We use human feedback to guide the model towards what we prefer.
So, like crowdsourcing feedback on which output is more engaging, persuasive, whatever we're aiming for.
Exactly. There are different ways to collect that feedback, but often it's as simple as showing people two responses from the LLM and asking, which one do you like better?
Seems simple enough. But with all those human preferences flying around, this whole thing seems like it could get pretty complicated.
It can be. One of the most famous techniques in preference fine-tuning is called reinforcement learning from human feedback, or RLHF.
Ah, yeah, RLHF, I saw that in your research notes. Pretty intense stuff.
It can be, but the core idea is pretty intuitive, actually. Think of it like training a separate model, a reward model. It learns to predict those human preferences based on the feedback we've collected.
So the reward model is like a guide for the main LLM, telling it what humans like and giving higher scores to outputs that will probably be favored by people.
Exactly. And the main LLM, being a good student, will try to get those high scores from the reward model. It's a way to bake human preference right into the fine-tuning process.
So like the reward model is saying, hey, LLM, if you want to impress us humans, this is the kind of stuff we like. But now I'm talking about the practical side of all this. We keep talking about these massive language models, billions of parameters. Isn't fine-tuning something that large, like super computationally expensive?
It is. It's a real concern, especially if you don't have access to, a supercomputer.
So what's the solution? Do we all need to go build our own AI labs to experiment with fine-tuning?
Not at all. That's where parameter-efficient fine-tuning comes in. PFT. It's all about achieving amazing results with a lot less computational cost.
Okay, I'm intrigued. Tell me more about this PFT magic. How do we make fine-tuning more accessible without sacrificing effectiveness?
We're strategic about it. Instead of updating all those billions of parameters, we just update a small set, the ones that matter most. It's like focusing your energy on the areas with the biggest impact, rather than trying to change everything at once.
Work smarter, not harder. Right. I like it. But how do we even choose which parameters to focus on? Is there a secret formula?
There are actually a bunch of different techniques for this, each with its own pros and cons, but one of the most popular and effective ones is called LoRa, low-range adaptation.
Laura. It sounds cool, but I'm having a hard time picturing what that actually does.
Imagine this giant library, right? Representing all the knowledge inside an LLM, LoRa is like adding these little bookmarks throughout the library. These bookmarks, they're actually trainable matrices. They guide the LLM towards specific information without rearranging the whole library.
So we're subtly influencing how the LLM makes decisions without needing to rewrite its entire knowledge base. That's pretty smart.
It is, and incredibly efficient. Because we're just training those small matrices, it's way less computationally expensive. Makes fine-tuning a lot more accessible for everyone.
No wonder Laura is getting so popular. It's like a shortcut to efficiency. But I'm guessing there are other techniques out there too.
There are, we'll get to those. But first, I want to address something I'm sure a lot of listeners are wondering. Why go through all this trouble to fine-tune the model itself? Can't we just use clever prompting to achieve similar things?
Right. We've talked a lot about prompt engineering, getting LLMs to do what we want. So why bother with fine-tuning?
That's a great question, and it comes down to the difference between prompting and fine-tuning. Prompting is like giving someone detailed instructions, how to complete a task using the tools and knowledge they already have.
Okay, so it's like giving someone directions or a recipe. They don't learn anything new. They just use what they know in a specific way.
A perfect analogy. Fine-tuning, though, that's like teaching them a brand new skill. You're changing the model itself at its core to be really good at a particular task.
So prompting is about optimizing the input, and fine-tuning is about enhancing the model itself. It's like, I don't know, giving someone a better map versus teaching them how to navigate by the stars.
Exactly. And prompting is great for some things, especially with powerful LLMs, but fine-tuning, that lets you push the boundaries, take that raw potential and make it specialized, powerful.
So fine-tuning is like a deeper change. You're not just guiding the model, you're expanding its skill set.
You got it. And that opens up a whole new world of possibilities for applying these LLMs to real-world problems.
All this is fascinating, and I'm already thinking about how fine-tuning could be used in so many different fields. But let's take a pause here. We've laid the groundwork, explored the core concepts of fine-tuning, and talked about how it's different from prompting. But next time, I want to dive into real-world applications. How is fine-tuning already changing the world? Stay tuned.
Welcome back. We're going to dive into those real-world applications, the stuff you sent in. It's pretty incredible how fine-tuning is changing things, everything from like customer service to actual scientific research.
Yeah, the potential is huge. One thing that really stood out to me was how it's changing chatbots. You know, those clunky things, most of them are just so frustrating.
Right. It's like those robotic interactions, they're just painful sometimes, but fine-tuning is changing that.
So instead of those press 1 for this, press 2 for that experiences, We're getting something that actually feels like a conversation.
Exactly. We're fine-tuning LLMs on like real conversations, customer service logs, even feedback from human agents so they get better at understanding what we actually mean, giving us the right information, even mimicking how we talk so it feels more natural.
It's almost like teaching them to be more human, more empathetic, more helpful, and way less likely to make us want to pull our hair out.
Exactly. And for businesses, this is huge. They can offer 20/47 support without needing a human there for every interaction. Plus, it's more personal, more engaging. Customers feel heard.
And I bet it frees up those human agents to focus on the really tricky problems that actually need a person. So it's a win-win. But let's switch gears a bit. Another thing that caught my eye was content creation. This one makes me a little nervous, honestly. Are we talking about robots replacing writers? Because I'm not quite ready to hand over my keyboard.
I get it. It's a scary thought. AI taking over creative fields. But remember, fine-tuning isn't about replacing human creativity. It's about amplifying it.
So instead of fearing the robot overlords, we should be thinking about how to work with them, like an AI writing partner.
Exactly. Fine-tuned LLMs can be amazing tools for writers. Imagine like getting past writer's block with the help of an AI that can brainstorm with you or generate different writing styles.
Like a built-in editor and writing coach, all in one. I could definitely use that sometimes.
And if you're creating content in multiple languages, fine-tuned LLMs are a lifesaver. Translation, localization, they can adapt to different cultures, make sure the tone is consistent.
Wow, that sounds like a dream for anyone who's ever struggled with translating content, making sure it works for different audiences around the world.
It is, and it's not just writing either. Fine-tuned LLMs are changing video and audio production too. They can generate scripts, create subtitles, transcribe audio, even those super realistic voiceovers you hear in documentaries.
That's amazing. Content creation is becoming so much more accessible because of these tools. And not just accessible, but potentially more diverse too. But we can't forget about like education and research. Those fields are all about sifting through tons of information, making sense of complex data. Seems like the perfect place for LLMs to shine.
Absolutely. They're made for this, right? They process tons of text, spot patterns that we might miss. In research, fine-tuned LLMs can summarize those super dense research papers, spot trends in the literature, even generate hypotheses based on existing data.
It's like having an AI research assistant that can speed up discoveries, help us make breakthroughs faster.
Exactly. And in education, the potential is huge. Imagine using fine-tuned LLMs to personalize learning for each student, give them instant feedback on their writing, adapt the material and how they learn best.
So education becomes more engaging, more effective, and accessible to everyone no matter their background.
Right. And then there's healthcare. Fine-tuned LLMs are already being used to analyze medical records, help with diagnoses, even personalized treatment plans.
Wow, this is getting really personal. The idea that AI can help doctors make better decisions and improve patient outcomes, that's amazing.
It is, but we can't forget, with all this power comes responsibility. As we use these models more and more, we need to think about the ethical implications, make sure they're fair, transparent, and that human well-being comes first.
Absolutely. It's a reminder that as cool as this technology is, it's a tool, and we need to use it to benefit humanity.
That's right. And with careful consideration, ethical development, the possibilities for good are just limitless. But we've covered a lot here. Why don't we take a short break and come back with even more mind-blowing examples of how fine-tuning is pushing the boundaries of what's possible?
Okay, we're back. Ready for more mind-blowing examples of how fine-tuning is changing things. You were about to tell us about some cutting-edge research pushing those boundaries even further.
Right. One area where we're seeing some amazing progress is personalized medicine. Like, imagine treatments that are tailored not just to your condition, but to you specifically, your genes, your lifestyle, even your preferences.
That sounds kind of sci-fi, but I guess with these fine-tuned LLMs, it's actually happening.
It is. Researchers are fine-tuning these models on huge amounts of data. Medical journals, medical trials, patient records, it's a lot. And they're building AI systems that can actually make sense of it all, provide really personalized insights.
So instead of that one-size-fits-all approach, doctors could have these AI tools to help them make decisions based on each patient's individual needs.
Exactly. These systems could help identify risk factors, predict how well different treatments might work, even suggest lifestyle changes, all to improve someone's health.
It's like having this team of medical experts behind the scenes, crunching all that data to give the best, most targeted care possible.
It is, and it's not just about individual patients either. Fine-tuned LLMs can analyze data from whole populations, spot disease outbreaks early on, even help with developing new drugs.
So we're talking about preventing diseases before they even happen. That's incredible.
It really is. And speaking of incredible, how about robotics? Fine-tuning is leading to some really cool advancements there, too.
Okay, now you're talking. Robots are always fascinating. What kind of stuff are we seeing?
Well, imagine robots that can not only do those precise physical tasks, but can also actually understand us, respond to complex instructions, adapt to new situations, even learn from their experiences.
Not those old, clunky, pre-programmed robots, right? We're talking about something more intelligent, like collaborators.
That's the goal. By fine-tuning LLMs on all this human language data, robotics researchers are building AI systems that can bridge the gap between what we want and what robots can actually do.
So we can just tell a robot what to do. Like, hey, robot, make me a sandwich. No more complex coding.
Maybe not sandwiches just yet, but you get the idea. It opens up all these possibilities for humans and robots working together. Robots helping us with daily tasks, working alongside us in factories, even caring for the elderly.
That's amazing. Robots become more than just tools. They become partners, helping us do things we never thought possible.
Right. It's exciting. And let's not forget about those immersive experiences like virtual reality, augmented reality. Fine-tuning can take those to a whole new level, too.
Now, that's where I can really see it making a difference. Creating those interactive worlds that actually respond to us, adapt to our preferences, the potential is huge.
It is. By fine-tuning LLMs on data from human interactions, gameplay, storytelling, we can build virtual environments that are way more realistic, engaging, and personal.
It's like stepping into your favorite video game or movie and actually being part of it. Characters that understand you, worlds that react to your choices, personalized adventures.
A dream come true for gamers, for anyone who loves stories. And beyond entertainment, this could change how we learn, how we train for things, even how we do therapy.
Wow. Learning history by walking through ancient Rome, practicing surgery without any risk, facing your fears in a safe environment. Mind-blowing.
It is. And as these LLMs get even more advanced, who knows what we'll see. It's going to be fascinating.
We've learned so much in this deep dive, from the basics of fine-tuning to how it's changing medicine, robotics, even virtual worlds. It's really incredible.
It is, and it's all thanks to these brilliant researchers, developers all over the world. They're pushing the limits of AI, constantly innovating, exploring new frontiers.
It's clear that fine-tuning isn't just some sci-fi concept, right? It's happening now.
Right?
And it's shaping our future in some really amazing ways.
It is, and as we keep moving forward, it's important to remember that responsibility piece. We have to make sure we use these tools for good, for the benefit of everyone.
Absolutely. We have to shape this technology in a way that aligns with our values, create a future that's innovative and equitable.
Well said. And on that note, I think we've reached the end of our deep dive. It's been a pleasure exploring this with you.
The pleasure was all mine. And to our listeners, thanks for joining us on this journey. We hope you're as excited about the future of AI as we are. Keep learning, keep exploring, and keep diving deep.